This is day 9 on our unit about circles. We are continuing to practice the relationships between angles and arcs in circles. So here we go. On this particular worksheet that I'm doing, I am going to do the odds. So problem number 1. As I do these problems, keep in mind this list of relationships that you need to know. You're not likely to be given these, so you better memorize them. Once again, they are, if the angle vertex is at the center, then the angle measure and the arc measure are the same. If the angle is at the edge of the circle, it's called inscribed, by the way, then the angle is half the arc, or you could say the arc is double the angle. If the angle vertex is floating around inside the circle, then we can deal with these two arcs. And it turns out the angle is the average or mean of the two arcs. So we just do arc plus arc divided by 2, and that will give you the angle. If the angle is completely outside of the circle, then it's almost the same formula, but instead of being arc plus arc divided by 2, it's arc minus arc divided by 2. Okay, notice that in each of these situations, the thing I write first is always the angle. Angle equals, angle equals, angle, angle. So you do the same thing. So when we look at problem number 1, this is situation 2. It's an inscribed angle. So the arc should be double the angle. So that's it, 37 times 2. So that's just going to be 74 degrees. All right, number 3, the measure of arc AB. Well, let's start with this inscribed angle. And again, the arc should be double. So arc BC should be double this. So that's going to be 54. Now let's use the fact that we have ourselves a diameter. This is a straight line, it's a diameter. This creates a semicircle. So this side of the circle should be 180 degrees. You know what I mean? If I go from here all the way around semicircle like this, that is 180 degrees. Alright, so if this part is 54, how can I find the other part, which I will show in blue? Okay, this is the thing that we're actually supposed to find, is arc AB. And hopefully you're realizing that I can just do 180 minus 54, and that should give it to me. And that is 126 degrees. Number 5. We are looking for the measure of arc AC. Okay, so this is our target, is arc AC. That's what we're eventually going to find. But we're not there yet, so let's start with this. We have angle that's 48 degrees right here. So if I double that, that should give me this arc. Alright, because it's inscribed, it's at the edge, so this should be double. So double 48 is going to be 96. Now you see how these two chords are congruent. That means we have some symmetry here. So that means the other two arcs are going to be congruent. So if I were you, I would start by subtracting this from 360, and then I would divide by 2. So I feel like changing colors though, so let's go to green. If I do 360 minus 96, I get 264. So that's what's left. So if I have to share that equally between these two sides, that means I'm going to divide by 2 and get 132. Alright, that's why arc AC, which is what we're supposed to find, is in fact 132 degrees. All right, number 7. All right, there's more than one way to do this, but let me just zoom in here. Here's the way that's most obvious to me. I know that, okay, we're supposed to find angle B. That's our target. But I know that angle B and angle C are always going to be the same. You know, anytime you have a bow tie situation like this, the angles on the same side of the bow tie are, well, they're going to be the same. So I'm just going to figure out angle C, and that's going to be my answer for angle B. So, you know, we have a triangle. So all the angles in a triangle have to add up to 180 degrees. So to me, the easiest thing to do is just subtract from 180. So this ink is too much. So I'm just saying, let's do this. These 3 angles have to add up to 180. So if I start with 180 and I subtract 116 and I subtract 32 and I see what's left, I see that that is 32 degrees. So that means that angle C is 32 degrees, which means that angle B is also 32 degrees. All right, and that's number 7. So let's move on to number 9. Okay. All right, there's probably more than one way to do this, but this is the way that I'm seeing first. A couple of things. First of all, this angle right here is 34 degrees. Again, it's another one of those bow tie situations, so I know that angles that are on the same side of the bow tie are going to be the same. So if this is 34 degrees, then this will be 34 degrees. So just file that away. Also, looking at this arc AB out here, all right, that arc is the arc that goes with these 2 angles. So these are inscribed angles, so I should be able to double the angle and get the arc. So if this is 34, then this arc measure will be 68 degrees. Keep that in mind, because I'm shooting for arc BC. So the more arcs I have, the closer I get to finding BC. So the next thing I'm going to use is just what I did on the last problem. Remember that the sum of all the angles in a triangle have to be 180. So I get really happy anytime I see 2 angles inside of a triangle, because I know I can find the third just by subtracting from 180. So that's what I'm going to do right now. So if I do 180 minus 124 minus 34, that should give me this missing angle over here. Do it. That turns out to be 22. So I know that this angle right here is going to be 22 degrees. Now, looking at the angle situation, this 22 degrees is this angle that goes right here. Okay, this is 22 degrees. That means this arc that goes with it is going to be 44 degrees. All right, so I've got yet another arc out of that. You know, I just doubled it. So now I have all of the arcs except for the one that I was looking for. So ultimately, we were supposed to find the measure of arc BC. BC is now the only one left. So I should be able to subtract everything else from 360. So if I just do 360 minus 68 minus 128 minus 44, that should give me the answer. And that turns out to be 120. That turns out to be 120. So arc BC is 120 degrees. All right, let's take a look at number 11 and stuff. Okay, alrighty. So we're using this picture. So the measure of arc CD is 85. So I better mark that. Let's start with green. CD. Okay, so this arc right here is 85 degrees. Okay. They gave us one other piece of information. The measure of arc BE is 97 degrees. All right, so BE, now I'm going to save that. Okay, there's arc BE, and they said that that was 97 degrees. Okay, so we've got that purple arc and that green arc, and somehow we have to use that to find all this other stuff. I'm sure this will come up, but notice that AC here is a diameter. So that's 180 degrees, so we have some semicircles happening here. So just watch out for that. I highly recommend using colors like I do. I think it'll help you. So let's see what we can do. Number 11, find the measure of angle CED. Okay, CED, you know what, I'm going to color that, maybe I'll do it in red. So CED is this angle right here, from C to E to D. So that's easy. We see that this angle reaches out and intercepts the green arc, 85. So I should be able to find this angle simply by dividing by 2. Cut it in half. So that is 42.5 degrees. All right, not so bad. Okay, that was number 11. Number 13, angle CBD. So let me start over. Okay, angle CBD is that angle right there. Well, that's exactly the same thing. It's yet another inscribed angle with the green arc is the intercepted arc. So once again, I take half, and so of course I'm still going to get 42.5 degrees out of it. All right, measure of angle BCE. Okay, and you see how I'm using these colors? And if you have a colored pencil or something, even just a regular pencil, but what you want to do is trace what you're given and what you're looking for so it really stands out. So there's angle BCE. All right, this is right the same situation, only this time the intercepted arc is the 97. But still, we should be able to find it by taking half to find the angle. So half of 97. So 48.5 degrees. Now, number 17. We're supposed to find arc ABC. Okay, arc ABC is going to overlap with the arcs that are given. So let me be real careful. I think I'll put it on the inside. So arc ABC is this arc that goes like this. Okay, that is arc ABC. Oh, well, that's pretty simple. Because don't forget that this segment AC is a diameter. So that makes this a semicircle, so arc ABC is 180 degrees. Thought I was going to have to do some work. In retrospect, all 4 of those problems were super easy. So we got off easy on that one. All right, let's move on and look for number 19. Okay. Determine whether a circle can be circumscribed about the figure. Well, that's just a matter of you have to remember the property that says a quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. Name the 2 angles in this picture that are opposite angles. Which 2 are opposite angles? Yeah, it's the 92 and the 89. Those are the opposite angles. If they're supplementary, then I will say yes. If they're not supplementary, then I'll say no. So let's just add them up. If we do 92 plus 89, what do we get? So close. That is 181. Okay, we were looking for 180 for supplementary. So, sorry, no, that could not be inscribed in a circle. So just please, please, please keep that in your mind. All right, so what about number 21? All right, these are the ones where we have to set up equations and stuff. So the two expressions that we are given are expressions for these angles right here and here. Are these going to be equal, or will they be supplementary, or what? Yeah, they're going to be equal. We've looked at a couple other bow tie problems already, and we've seen that anytime we have this bow tie situation, angles on the same side of the bow tie, like B and C, will always be congruent. And that is what we have happening here. These two angles should be congruent, so I can simply set them equal to each other. So that's what I'm going to do. So it'll be like this. I will do 2x plus 11 is equal to 4x minus 3. I would subtract 2x from both sides, and that will give me 11 is equal to 2x minus 3. And then I would add 3 to both sides, and that's going to give me 2x is equal to 14. And then I would divide both sides by 2. Alright, and that is going to give me x equals 7. Alright, so that's how you do number 21. Let's take a look at number 23. Well, check it out. Once again, we have a quadrilateral inscribed inside a circle. It's sort of like what we were talking about when we did problem number 19. If you have a quadrilateral that was inscribed in a circle, the opposite angles have to be supplementary. They have to add up to 180. So here we have a quadrilateral inscribed in a circle. So these will be opposite angles. So this angle and this angle, they should add up to 180. So I'm just going to set up an equation that's basically saying that the first angle plus the opposite angle should equal 180 degrees. But instead of the word angle, I'm going to put in these expressions to represent those angles. I'm trying to see where I have room to do this. I think I can do it down here. So that means 3x minus 8, which is one angle, plus 5x plus 2, which is the other angle, should equal 180 degrees. So now it's just a matter of solving this equation. Shouldn't be too hard. Since this is addition, the parentheses don't really matter. You know, I could erase the parentheses if I wanted to. Bling bling. So now I'm just combining like terms. The 3x and the 5x go together, so that's 8x. And meanwhile, the negative 8 and the positive 2 go together, so that's going to make negative 6. Equals 180. So go ahead and add 6 to both sides. So that's going to give us 8x is equal to 186. Time to divide by 8. Divide by 8, divide by 8. So that is going to give us x equals 23.25. Alrighty then. That is how we do that. Last problem, number 25. And we are supposed to do all of these variables, find them all. So let's just do them one at a time. So say if we want to find angle X right here. Angle X, it will make it easier if we highlight it. Whoops, I'm getting off track already. Angle X is this angle right here that goes like this. Okay, so the question is, what is the arc that goes with that? Well, the arc that goes with that is the one that looks like this. Green. It's the arc that goes from one end of this angle to the other. So it's this green arc that I'm drawing right now. That is the arc. X is an inscribed angle, so if I take this green arc and I do half of it, that should give me X, shouldn't it? But wait a minute, what is the green arc? It's just the 81 combined with the 51. It's both of those put together. So that is 132 degrees altogether. So half that is 66. So X is 66 for that reason. Alright, so we have X. Keep that in the back of your mind. In fact, I think I will go ahead and put a 66 right here to remind us of what we have discovered here today. But I'm going to erase the rest of it to make room for my other calculations. So we found X, fine. Let's see. We can find W just as easily. So I'm going to skip over to W. Let me go back to red. It's always easy to see red. So W, this angle right here, if I trace it, makes it more clear. So W goes from here to here. That is angle W. And the intercepted arc that goes with that is this purple arc that goes like this. Alright, that is the intercepted arc. But how many degrees is that intercepted arc? Well, that's just going to be the 51 plus the 79. So that is 130. And so of course if I divide that by 2, that should give me angle W. Half of 130 is 65. So that is 65. So W is 65. I feel like I should put this in alphabetical order. W, X, Y, Z. So W is 65. All we have to do now is find angle Y and angle Z. I don't have to do anything fancy to find them. I can use what we've been talking about just recently. Opposite angles should be supplementary when you have a quadrilateral inscribed in a circle. So what I'm saying to you is that these two angles are opposite angles, the 65 and the Y, for example. These are opposites. So if I add them, I should get 180. So I'm going to tone this down a bit. Maybe one notch should do it. So if I do Y plus 65, then that should add up to 180 degrees. They got to be supplementary. So of course that just means I subtract 65 from both sides. And that should give me Y equal 115. Alright, great. So Y equals 115. And I'm going to do Z in the same way. So when I go to do Z, again, I know that opposite angles have to be supplementary. So these two have to add up to 180. So Z plus 66 has to equal 180. Just subtract 66 from both sides. And that gives you that Z equals 114. All right, and that's how you do it. We found all 4 angles. Not too bad. All right, and that is the end of this lesson. If I was able to teach you anything today, helped you with your homework, please help me out and give me that thumbs up, hit like. It will help me a lot. Thank you very much. See you on the next video.